We're going to continue our unit on random variables today and talk about continuous random variables. Up until this point, we've mostly worked with discrete random variables where the outcomes are separate, countable values, like if we want to know the number of heads in a coin flip. But many real world measurements are continuous. Things like height, weight, time, speed, and test scores, they can take on infinitely many possible values within a range. So in this lesson, we're going to explore continuous random variables using probability density curves. And we're also going to look at the normal distribution. We're going to learn how probability is represented as area under a curve and also why the total area has to equal 1. We're also going to learn how to interpret probabilities for intervals of values rather than just a single point on the graph. So let's take a look at the first example here for probability density curves. This problem says, consider the density curve below. Find the probability that x is more than 3. So we're working with a density curve, and this represents what's called a continuous distribution. So instead of listing all the probabilities at specific values, the probability comes from the area underneath the curve. So where x is greater than 3 is from just after 3 and everything after 3. And 5 looks like it's the greatest value at 5. And so we really want to find the area here. So I would say that's our first step is draw the area under the curve. In this case, it's a triangle. And then we just want to calculate what that area is. So the area of our triangle is going to be 1/2 base times height. So the area of our triangle is 1/2 times our base is the distance from 5 to 3. Distance is we subtract the absolute value. So 5 minus 3 times the height is 0.6. And this just ends up being positive 2 times 0.6. And I'm sure you're familiar with how to calculate the area. So you just get 1 times 0.6, and the area is 0.6. And so that's the probability that x is greater than 3. Now it's just a coincidence that this 0.6 is that 0.6 there. That doesn't mean that it was 0.6 because that was there. So just keep that in mind. All right. Let's take a look at the next one. So the next one is the density. It wants us to consider the density curve here. This we just have a straight line, and we want to know the probability that x is less than 4. So we want to find where x is equal to 4. We'll draw a line there. And we're going to draw our other line at 1 because the blue line on the density curve stops at 1. So we would not go to 0. We're going to go to where it stops. And so we're just going to find the area under that curve. Very straightforward. Area is base times height. And we're going to find the absolute value of the difference between the 2 points for the base. 4 minus 1 times the height is 0.25. And so that gives us positive 3 times 0.25. And so the area is 0.75. And that's the probability that x is less than 4. So that's how to find probability with density curves. You occasionally might get some other shapes if you happen to ever need to calculate area of any kind. You can always break down the area into more manageable shapes like multiple rectangles or rectangles and triangles, or sometimes trapezoids. That's kind of a side note there. All right, now we're going to look at probability in normal density curves. So when we talk about a normal density curve, this is there's two graphs here that show us the normal distribution. And these are from the z tables. We're going to take a look at these z tables in some more detail in just a moment. But the normal density curve gives us a normal distribution that we can then use the z tables to find information about. Now notice on the z table we have things shaded in here. That's essentially the area under the normal distribution curve. So when we have a normal distribution and not something that is irregular like our first two examples, we can use the z table in a normal density curve. So let's take a look at this first question and see what it's asking us to find. It says that there's a set of biology exam scores and they're normally distributed with a mean of 70 points and a standard deviation of 6 points. Let X equal the score on a randomly selected exam from this set. Find the probability that X is less than 73. Okay, so in order to do this, the first thing we need to do is calculate the z-score for this. So we want to find the z-score. And to find the z-score, the equation is x, our individual data point, minus mu, our average, divided by the standard deviation. In this case, we're going to let x equal 73. It tells us the mean is 70 in our given information there. It also tells us the standard deviation is 6. And so now we're going to simplify this. This becomes 3 over 6, and z equals 1/2 or 0.5. Okay, now we want to check the z table. So let's zoom out a little bit here. We know we're looking for z equals 0.5, and I put both of the z tables on here. If it's helpful for you to take a screenshot of this, let me just move this up so you can if you need to. These are This is a good Z table in my opinion. So if you need to take a screenshot of this, that's great. If you already have one in your book or somewhere else, that's good too. So we're gonna look for where Z is 0.5. And here we can see Z is 0.5. These values on the top represent the hundredths. So if it was like 0.56, we would go to the 0.06 and we would trace along like this to find where they intersect. So that's what those numbers are. But this is just 0.5. So we're looking for 0.50, which is this first value right there. Okay. So now we can say that with these z tables, this z table is telling us the probability that z is less than 0.5 is 0.6915. So on our normal distribution, if we wanted a z-score of 0.6915, we could say maybe it's somewhere around here where our z is. We're going to say the area that this represents is approximately 69.15% of the probability. So to rewrite this, we can say that the probability that x is less than 73 is equal to the probability that z is less than 0.5, which is approximately equal to 0.6915, or approximately 69%. So by by converting our values into z-scores, it tells us how many standard deviations that a value is from the mean. And this lets us take any normal distribution and compare it to a standard normal distribution, which has a mean of 0 and a standard deviation of 1. Let's take a look at one that's a little more complex so we can get a better idea of what the z-score is even telling us. Because right now we're looking at z-scores that are less than, which includes where z is and everything to the left. Even if our z is a negative z-score, it's still less than, so it's including all of the area to the left of z all the way to the very end point. But we're going to take a look at another question next that asks us to find the probability that x lies between two values. So here's our next question. Same type of question. It says it's a biology exam score and they're normally distributed. We have a mean of 70, standard deviation of 6, same thing as before, except now it says to find the probability that the exam scores that a randomly selected exam is a score between 64 and 76. So we want to find the probability of that occurring. So we're going to compute the z-scores of both values for 64 and for x equals 76. So z is going to be equal to x, which is 64, minus the average, 70, over the standard deviation, 6. And for this one would be 76 minus 70 over 6. So now we get negative 6 over 6, and z equals negative 1 for when x is equal to 64. For when x equals 76, you get 6 over 6, z equals positive 1. So those are nice z values to find on the table. They're says negative 1 and 1. So those are pretty easy to find here. But let's take a look at where they are on the table. So negative 1, and the other one is positive 1. All right. So the table only gives us left-sided probabilities. Here's what we're actually trying to find. We're trying to find the probability that z is between negative 1 and 1. And here's what that would look like on the normal distribution. We want to find what's the probability, or what's the area going to be under the curve between negative 1 and 1 on our z-score table, or our z table. Now, in order to find that, since our table only gives us left-sided probabilities, let's take a look at what the probability of z is less than 1 would look like on the table. So if we had z is less than 1, we would start at 1, and we would shade everything to the left of 1. But we just want that middle region. We really just want this part. So we really just want that part. So what we're going to do is we're going to subtract out this part. We're going to subtract out where the probability of z is less than negative 1. That's what we're going to subtract out of this. So putting this all together, what our final equation is going to be is we're going to say that the probability that z is between -1 and 1 is equal to the probability that z is less than 1, which is all of, erase this real quick here, the probability that z is less than 1, which is everything here. And then we're going to minus the probability of z being less than -1, which is in the red here. And maybe I should have written that in red. Actually, let me do that. That might be a little more helpful. So we're going to minus the probability that z is less than -1. And that's going to give us the middle region that we're looking for, this middle purple region here. Okay, so we've calculated what those values are. We've calculated that the probability of z is less than 1. We found that on our table. And if we go back to our table, we'll find where z is equal to 1 on our z table, and we get 0.8413. So go back here, and this is 0.8413. And then we're going to subtract the probability of z being less than -1, which is also on our table. And that's going to be there in the yellow, 0.1587. And so we're going to subtract these two values, 0.1587, and that's going to give us 0.6826. And the problem is asking us to round to the nearest hundredth, and so that's going to be about 0.68. And this is the probability of z being between -1 and 1. Okay, so let's do a quick recap on what this question's saying. So it's asking us to find the probability um, that the score is between 64 and 76. And so we're assuming that this is on a normal distribution, so we can use the z-table to equate a z-score of being equivalent to what those scores are. And so our final answer again is going to be 0.68 for this one. All right, let's take a look at one more here. This one is asking us to find the probability that x is greater than 25. And I included this problem in here because, again, our z-score table, when we're looking at z-scores, it represents values that are less than. And this is asking us to find the probability that x is greater than 25. This one's not about test scores. This one's it's about cars from a car dealership, and it says the sale prices for a particular car are normally distributed with a mean and a standard deviation of $26,000 and $2,000 respectively. So that's just another way of saying respectively just means in that order. So the mean is $26,000 and the standard deviation is $2,000. It says, suppose we select one of these cars at random. Let X equal the sale price in thousands of dollars for the selected car. Find the probability that X is greater than 25. Okay, so we're going to do the same first steps here. We're going to find the z-score. So to find the z-score, that's X minus mu over standard deviation. And our X value is 25. This is in thousands, so 25,000, we're just going to write 25, and 26,000 is the average, so 25 minus 26. And then the standard deviation is 2. So now this is -1 over 2. -0.5 is the z-score that we're looking for. Now let's find what that is on our z-table. So we have -0.5. Looks like we've got 0.3085. Now this z-score this is associated with the probability that z is, excuse me, we're going to say that the probability that x is greater than 25 is equal to the probability that z is greater than 0, excuse me, is greater than negative 0.5. Okay. Now we don't have the z table for z is greater than negative 0.5. We only have the z table information for z is less than negative 0.5. So we're going to use the complement rule. So the probability that z is greater than negative 0.5 is equal to, by using the complement rule, 100% or 1 minus the probability that z is less than negative 0.5. Now let's take a look at how we can visualize this on the z table, on the normal distribution. So we'll start by plotting negative 0.5. It's probably about there. And we are looking for where z is greater than. So we want to find the area here. So in order to do that, we could find 100% of the area minus all of this to get the black region that we're looking for, or the probability that z is greater than negative 0.5. So that's how we're using the complement rule, and that's how that would look visually on the normal distribution. Okay, so we were able to calculate what the probability that z is less than 0.5 is from the z table, because when z is less than, we have those z table values. So we're going to say 1 minus 0.3085. And this gives us 0.6915, rounded to 2 decimal places, is 0.69. And so that is approximately the probability that x is greater than 25. All right. So hopefully that was some good review for you as well, looking at z tables and being able to understand the complement rule, and also how to calculate these areas under the normal distribution.